ladies and gentlemen, President ISL, President of the Sectional Committee, Electrical Sectional Committee, ISL, past presidents, council members, Executive Secretary, and distinguished guests, ladies and gentlemen, dear friends. Okay. First of all, let me thank the Chairman of the Sectional Committee, Electrical Sectional Committee, for inviting me, and also the President of IESL for inviting me to do this distinguished lecture. And also, I would like to thank for all the coordination that was done by the IESL staff and the other members for successfully completing this lecture. I have got a few slides here. It's not a slide presentation, and in black and white in your notes. So once again, I thank Mr. President for the kind introduction of me to this learned crowd at this historical important event of the 34th Professor R.H. Paul Memorial Lecture, organized by the Electrical Engineering Sectional Committee of the Institution of Engineers, Sri Lanka. One of the best qualities of human beings is being grateful, and the modern society lacks it. So all our commemorative lectures held at these premises, each time they are conducted, sends a message to the country and the world that we engineers are a grateful race, with that engineers are robots. Late Professor Robert Hoisington Paul has been acclaimed as the father of electrical engineering education in Sri Lanka. His farsightedness, enthusiasm, and dedication on what he chose to work upon have won him great honors beyond his professorship, and today we, the engineers who have not even had personal contact with this great teacher, speaks high of what he did and what he is remembered for. In this presentation, I am sharing with you some of my thoughts and experiences in teaching the subjects on energy and environment to both undergraduate as well as to postgraduate students at the Department of Electrical Engineering, University of Moratuwa, for the last 10 years. Engineering has reached far heights since the Industrial Revolution some 200 years back. Inventions of electricity, internal combustion engine, digital computer, mobile communication, the internet, and similar many others have built a world beyond the imagination of 10 Arthur C Clarkes put together. Further up, the marvels of medical sciences have challenged every conceivable illness except a few such as AIDS. Final results of all these has been an outburst of population, which in turn has caused a spiraling increase in the demand on all sources, all resources, and especially on energy. Figure 1 shows the world population growth for the last 10,000 years with a vertical scale on logarithmic scale in your paper, and on the screen you can see it's on the natural scale. And it is interesting to note that 2000 years ago, when Lord Buddha was living and preaching Buddhism, the world population had been just under 100 million people. It's also interesting to note that 200 years back, the world population has been around 1 billion. And during just last 200 years, the population has exploded to 7 billion mark. There is profoundly a strange turning taking place in the human history. UN estimates the population to cross the 10 billion mark by the end of the century. The enormous pressure exerted by this huge population on the environment, food supply, and energy is unprecedented, and repercussions of climate change are felt all over the world. Meter-thick snowfalls in North America, flash winds, flash rains, flash floods in many countries including Sri Lanka, heat waves in Europe, India and other countries are not the same news stories we were used to hear some 30 years back. The fifth assessment report, what we call the AR5 on climate change, was issued by the Intergovernmental Panel on Climate Change, IPCC, just last year. and the climate change. Engineers and scientists working in the energy sector can play a decisive role in controlling GHG emissions and finding alternative ways to keep energy demand met. In this context, though Sri Lanka is a low carbon country, we need to be conscious of the local as well as global responsibilities for the sake of our future children, who remember us as far-sighted great parents in the same way we commemorate Professor R.H. Cole today. Our planet, beautiful to look at from the space. Our planet is the third from the sun in our solar system. Astronauts are yet to find conditions for life, though their explorations have extended millions of kilometers into the space. On this globe, with an average diameter of about 12,700 kilometers, we live at the bottom of the atmosphere. It is taken for granted that the atmosphere to be inexhaustibly large and having comparable dimensions with the Earth. Unfortunately, this gut feeling is wrong, and the atmosphere is surprisingly thin. Scientists have estimated that 75% of the total mass of the atmosphere is within the first 11 kilometers, though the last traces of air molecules may extend up to about 1,000 kilometers. First 11 kilometers distance, planes take their flights, etc. It is into this thin atmosphere we started to emit carbon dioxide-lit greenhouse gases starting from last 200 years. This is a novel experience for all and particular to the nature. As indicated in the figure 3 in your notes, world has been carbon neutral until recent times. Biomass catches carbon dioxide through photosynthesis from the atmosphere and release the same when burned to release energy. Unfortunately, by today, the contribution from biomass has become less than 10%, and oil, coal and gas, all of which are fossil fuels, have taken over. Contributions from nuclear is also limited. Still, the contribution from new renewables sources such as wind, solar and small hydro is not significant. Large-scale utilization of fossil fuels started only after the invention of steam engine, steam turbine and internal combustion engine. Automobiles, steam and diesel electric trains, as well as production of electricity unleashed the fossil fuels, the sleeping ghost from the underground caves. However, not until last part of the 20th century, the scientists were able to relate greenhouse gases as the culprit for warming the planet. Greenhouse effect. Part of the surface, etc. and part is absorbed by Earth as well as particles in the atmosphere. Earth radiates this heat back into the form of infrared radiation, most of which generally end up in the space. This heat is absorbed by molecules such as carbon dioxide, methane, nitrous oxide, which we term as now as greenhouse gases, and they re-radiated the heat in all directions, and part of it comes back to Earth. Thus, these gases act as a greenhouse, and more such gases are present in the atmosphere, more will be the heat. And even life may not have been supported. But starting from year 1800, time when we started to burn fossil fuel in bulk, the carbon dioxide concentration has steadily increased. As the figure 5 indicates, CO2 concentrations, which was about 280 parts per million before the 19th century, has increased to about 350 parts per million by now, and it is steadily on the increase, as scientists have estimated at a rate about 1 ppm every year. Figure 6 depicts the average global temperature increase during the last 150 years, which shows a definite tendency for the continued increase. One may ask the question, take the question lightly, that this 1 degree of increase is global, and the enormous amount of heat that has been retained due to greenhouse effect for this increase. Figure 7 shows the rate of release of carbon dioxide to the atmosphere since the Industrial Revolution due to anthropogenic activities. In 1950, the carbon dioxide rate has been 5 billion tons a year, and just in 60 years, in 2010, the rate has been increased by 7-folds to 35 billion tons a year. Intergovernmental Panel on Climate Change, what we call IPCC. IPCC is the organization to provide the world with a clear scientific view on the current state of knowledge on climate change and its potential environmental and socio-economic impacts. IPCC comprises of 3 working groups and a national task force. Working Group 1 works on the physical science basis of climate change. In their recent reports, this group has conclusively identified the contribution of GHGs in warming the globe. We must remember that there were times that some strong countries even challenged the idea that the global warming was due to greenhouse gases. Later studies revealed that those views were more based on politics rather than science. Working Group 2 identified of mitigating the impacts of climate change. Task Force on Greenhouse Gases inventories assesses the nationwide emissions of greenhouse gases. Greenhouse gases. Scientists have identified carbon dioxide, methane, halocarbons and nitrous oxides as the main culprits for global warming. Increase of carbon dioxide concentration due to burning of fossil fuels and dwindling of forest cover is the major contributor for greenhouse effect. As per the latest findings, contribution for global warming by carbon dioxide is 1.7 times that by methane. Contribution from halocarbons and nitrous oxide together is about 1/3 due to climate change are quite emphatic. Warming of the atmosphere, heat waves, melting of glaciers, sea level rise, extreme weather, ocean acidification, mitigation of migration of insects to different geographic areas are some of the major impacts of climate change. Warming is obvious. We had never heard of heat waves when we were young. Heat waves in India and some parts of Europe in summer has become a norm. Every year hundreds die in our neighboring India, and worst of all, the most vulnerable are the poor street dwellers. 2003 European heat wave was the worst, causing the death for several tens of thousands. In Europe, of similar magnitude to occur in the coming years. Extreme precipitation is already in experience. The precipitation rates are often higher than discharge rates of drainage systems, causing flash floods. What happened in North Central Province in December last year and many flash floods in our cities are classic local examples. Sea level rise will be a serious concern, particularly for low-lying islands. Maldives is already in search of alternative land elsewhere in preparation for what is forthcoming for them. Melting of glaciers pose 2 problems. One is obvious sea level rise. Second is the reduction of what we call the albedo, the so-called reflection of incoming solar radiation back to absorb, aggravating the situation. Kyoto Protocol. The Kyoto Protocol is an agreement under which industrialized countries were to reduce their collective emissions of greenhouse gases by 5.2% compared to year 1990. The agreement was signed in 1997 and came into force after ratification in 2005. Though US, the biggest polluter of the world, signed the agreement, they refused to ratify. The reductions were to come during the period 2008 to 2012. Carbon trading and clean development mechanism are the creations of Kyoto Protocol. By the committed reductions of GHG emissions. Post-analysis indicate that major drawback of the Kyoto Protocol was that it had no compulsory targets for India and China, which subsequently became the major GHG emitters due to two-digit economic development rates and massive populations in the two countries. The year 2012 dawned and dusked, and so did the commitments of Kyoto Protocol. The pending argument is the developed countries argue that countries should be allowed to emit greenhouse gases according to the present pattern, and reduction should come their own, while developing countries, especially China and India, with over 1 billion people in each, argue. In December, Secretary General of UN, Mr. Ban Ki-moon, in his address at the launching of the 5th assessment report of IPCC, was hopeful that an international agreement could be reached by 2016, but the world community remains skeptical due to the enormity of the problem. However, different countries and regions have set their own targets for renewable penetration. For example, EU has a first target of 20% of electricity from renewables by 2020 and a second target of 50% by 2050. Sri Lanka has a similar target of achieving 10% electricity by 2015 and 20% by 2020. The first target we have almost achieved, but for the second target we are not. Ladies and gentlemen, now I turn towards energy sector and the electricity sector, which is professionally more relevant to us, the electrical engineers. Michael Faraday, the hailed English scientist of 20th century, a poor blacksmith's son who did not even get a formal education, might have had second thoughts of divulging the invention of electromagnetic principle had he known that his invention is going to put the planet Earth in so serious a trouble. So would have thought many other scientists and inventors. We have become so energy intensive that we cannot think of living without electricity and automobiles. But remember, just 200 years back, roughly about 4 were their culture inferior by any standards to ours? Didn't they travel on land and seas as they wanted? They did all this but remain carbon neutral. If I take myself as an example, Lord Buddha said, Attana Mupama Katta, take yourself as an example. I need my car to run about 3,000 kilometers every month, which correspond to roughly about 300 liters of petrol. That means 10 liters of petrol a day. I drink only 2 liters of water a day, and so do many of us. The conversion efficiencies. Although there have been mild improvements in energy conversion efficiencies, groundbreaking efficiency increase and average automobile fuel efficiency lies in the range of 10 to 15 kilometers a liter, while the vehicle engine efficiencies are around 15 to 20%. What does it all indicate? We are wasting a hell of a lot of fuel. From every liter of oil, we waste 60% of energy when we generate electricity. And when running an automobile, more than 80% is wasted. One day, our future scientists may come out with technologies which may have double the present efficiencies we have achieved. But alas, they might be too late, as by then fossil fuels have become things to be seen in lab scales and museums, and they might have many names to call us who wasted such a burning of coal in power plants emit on average about or nearly 1 kilogram of carbon dioxide for every kilowatt hour it produces. Similarly, other fuels also emit varying amount as shown in the table 1. Similarly, carbon dioxide emissions when fuel is burnt in automobiles and other equipment are shown in table 2. We can see when we burn 1 liter of petrol in our car, we release about 2.3, slightly over 2 kilograms of carbon dioxide into the atmosphere. New renewable energy and nuclear. Solar, wind, small hydro, biomass and a few similar other sources are categorized as NRE or new renewable energy sources, and scientists have second thought of a reservoir which has many environmental impacts, and the latest findings indicate these reservoirs are sources of methane, which is also a greenhouse gas, due to the perishing of submerged as well as the incoming vegetation. Nuclear is expected to play a vital role, but with half a decade of experience, still the contribution from nuclear is under 3%. Chernobyl and Fukushima accidents have made such public opinions that many nuclear countries have taken decisions either to entirely stop nuclear programs and even to decommissioning the existing plants. Solar energy, the most commonly available energy in the last 10 years. Photovoltaic panel prices have slumped down, and concentrated solar power, what we call the CSP plants, are getting popular in many countries. The biggest hurdle to overcome in solar PV is its unacceptably low efficiency of energy conversion. Most commercial panels with right prices have efficiencies in the range of 10% to 12%. This is where our scientists have to step in and come out with innovative techniques to improve efficiencies. CSP technology provides heat storage, and thereby the operation of the power plant can be extended to night hours as well. Another are very expensive. Thus, engineers and scientists are called upon to develop better technologies for efficient and economical energy storage. Development in wind power sector has also been significant. 8 to 10 megawatt unit sizes are into the commercial operation by now. Wind has the drawback of being seasonal as well as intermittent. In the off season, the grid operator should have alternative sources to meet the demand, and the intermittency calls for ready hot reserve power, which is expensive. Pumped storage power plants provide a solution against the intermittency, but it also makes an additional cost. Biomass, being a carbon neutral source, has great potential in aiding sustainability of them. Biofuels such as palm oil and ethanol are also substitute for fossil fuels. However, diversion of bioproducts to energy market may threaten the food supply chain to ever increasing world population. Tidal energy, wave energy, ocean thermal energy, geothermal, etc. are yet not in the leading commercial operations due to either to resource limitations or technological limitations. Again, our scientists and engineers have to make new innovations as how to convert these sources to electricity economically. The solutions to address the climate change issue, fossil fuels, burn less or no fossil fuel. Of course, this is easily said than done. IPCC has estimated that if we are to keep the global average temperature increase within 2 degrees centigrade by the end of the century, the total cumulative carbon dioxide emissions since 1870 has to be kept under 2,900 billion tons. 2,900 billion tons. As shown in figure 10, from 1870 to 2011, we have already emitted 1,900 billion tons of carbon dioxide into the atmosphere. For the balance 18 dioxide, and when we refer to figure 7, we notice that we are at present emitting at a rate of 35 billion tons per annum. So 35 billion tons per annum, and by the end of the century the quota is only 1,000 million tons. And even at this rate, we finished the remaining 1,000 billion ton quota in less than 30 years. And we should remember this 35 billion tons per annum rate is also going up. Thus, we need drastic changes in our way of life. The way we generate electricity, the way we handle our forests, the way we travel, and so on. If we are to contain the average warming to 2 degrees centigrade by Sri Lanka. We can be proud that we have reached $3,000 per capita GDP while still having low per capita emission of 0.6 tons of carbon dioxide. In the world as well as in the region, we are a low carbon emitting country. We can justify that we have a natural right to emit more for our economic development. We need cheap energy and therefore we have no option but to go for cheap power generation technologies. We can also look at the problem in broader terms. Industrialized countries, when they were emitting CO2 for their cheap power, the world was unaware of the climate change problem or its assessment report indicating that it is most likely that greenhouse gases are causing the climate change. To the argument that everybody has the same right to emit, we can be fairer in our thinking that those who are living in cold countries such as Scandinavia need more energy for mere survival and probably deserve a better carbon quota. But one thing is clear, whoever emits, the problems are common to all. Whether a polluter or not, every country will have to take their share of consequences. A low emitting country can be unlucky and may have to face the hardest environmental calamities. Carbon footprint. From the are born, starting from the energy needed to produce the very napkin we are covered with by our dearest mother, until about 25 kilograms of LP gas required to burn our coffin, we keep on emitting carbon dioxide in numerous ways from the cradle to the coffin. When anything new is used, be it a cloth, pen, shoe, book, paper, car, simply anything, some kilowatt hours or joules have gone into production of it, and there is an associated carbon dioxide emission unless the source of energy is renewable. For the production of processing of food we eat, some energy has gone in and there is a corresponding amount of carbon dioxide. So every day we cause to emit certain amount of carbon dioxide to the atmosphere, and at the end of our journey we can add our final emission corresponding to the burning of the coffin with our body inside. This total grand figure of carbon dioxide emission, when added up, will stand at so many tons against our name, and that is the carbon footprint we are leaving behind us. To make our carbon footprint larger or smaller is entirely up to us. When we postpone buying a new shirt and reuse what we have for another year, we reduce our carbon footprint. When we eat fresh chicken rather than eating frozen chicken, we reduce our carbon. We reduce our carbon emissions because processing meat requires energy. When we use public transport rather than travel alone in our car, or when we travel with more people in our car, we reduce our carbon footprint. When we travel less by air, we reduce our carbon footprint. Simply speaking, when we reduce the use of resources, we reduce our carbon footprint. If we want our children not to scorch in heat waves, we have to do it. If we do not want our children to live in deserts, we have to do it. If we do not want our children to be environmental refugees due to unbelievably hard rains, hurricanes, typhoons, floods, late engineer Professor R.H. Paul will rest in peace, feeling their job well accomplished. Thank you very much, ladies and gentlemen.
Thank you, Engineer Wijayapala, for your informative lecture. Now we move on to the next item, that is to present a memento as a token of appreciation. I would invite the President to hand over the memento to the We have now come almost to the end of the lecture. I will call upon the Chairman, Electrical and Electronics Engineering Sectional Committee, Engineer Kosala Kabradaniya, to propose the vote of thanks.
Good evening. Engineer SP Vijayapala, the President, Institution of Engineers, Sri Lanka. Engineer Shavindranath Fernando, Immediate Past President, IESL. Engineer Ms. Arundhati Vimala Surya, Executive Secretary, IESL. Guest Speaker, Engineer Anura Wijayapala, Chairman. Presidents, Vice Presidents, Council Members, Members of IESL, Members of Electrical and Electronics Sectional Committee, and ladies and gentlemen. First and foremost, on behalf of the Institution of Engineers Sri Lanka, the IESL, let me thank Engineer Anura Wijayapala for readily accepting our invitation and for being with us here today in spite of his busy schedules as our guest speaker to deliver this prestigious Professor R.H. Paul Memorial Lecture, which, as you all know, is one of the most important annual events of IESL calendar. Moreover, we are indeed thankful to you for the selection of one of the most appropriate topics and giving insight this environment and context. Also, on behalf of the Electrical and Electronics Sectional Committee, I would like to thank President Engineer S.B. Vijayapala, Executive Secretary Ms. Arundhati Vimala Surya, and the Secretariat for making this event a success. Special thanks should go to my colleagues in the Sectional Committee for organizing this event. Also, last but not least, ladies and gentlemen, let me thank President-elect, President, past Presidents, Vice President, Council Members, invitees, and every one of you for taking your time to be with us to participate in this year's Professor R.H. Paul Memorial Lecture. Thank you.